Okay, so now we're on section 7.4, that is the sample size. So we've talked a lot from the introduction, some from 7.2 and 7.3. Now we're on 7.4, that is sample size consideration. So we want to actually get a minimum size, sample size n. So always we've been given the n, but now we want to find the n, given some information, okay? But always realize that the n can be found at the E part, all the formulas that you've seen from constructing the interval estimate, you see that the n will be at the e part. So that's why you consider the e aspect of it. And when you take the e by change of subjects, you're going to find your n. So after doing everything, we get the n to be like this. Okay, so that's the formula for the n. And this is the estimated minimum sample size n needed to estimate a population mu. So if you're talking about the population mu to within E, so you see the word within and a number comes, then that is your E. So in a question, you receive within 10, then it implies that your E is 10. Within 5, then it implies that your E is what? 5. Okay. So the within and the number that comes is your E. Finished at, okay. So we know all the terms here. So we want to consider some example. So use the formula, then you do what you want to do. We know how to find Z alpha over 2. The sigma will be given, the within, and the number that comes is your E. Okay, so let's check this example. So economists wishes to estimate with a 95% confidence interval. Okay, so we have our 6 alpha is what? 5%. Divide by 2, that's 2.5%. Okay, so Z alpha over 2 here is what? 1.96. You are good to go. So we know our Z alpha over 2. So what again? We know what we have to get our sigma. You have to get a sigma. So now we know Z alpha over 2. You have to get the sigma, okay, and get your E. Then you find your N. Whereas to within, so within, what number comes here? That is 1,000. So your E is now 1,000. She estimates that the range of income is no more than, okay, it's no more than 25,000. So using the empirical rule, she estimates that the population standard, so the sigma, the population standard deviation is about 1/6. So 1/6 is that you multiply 1/6 times the value here, or they've calculated it to be at 4,000 for you. So your sigma is also given. So I think we have everything that we need to get our n. So we have to find the estimated minimum sample size. So we have to find our n required. Okay. So by the formula, Z alpha over 2, 95% confidence interval, Z alpha over 2 is 1.96. Or you can use all the formulas there, all the numbers. But if you write 1.96, I think you should get the same answer as someone who writes everything there. But you just round it up. I don't think, yeah. So just do that. And you fill in the formulas. So what you do is that our n will be equal to Z alpha over 2 is 1.96 times what our sigma, which is in the question, which is 4,000, all over E, which is 1,000. Then we square everything here. So we solve what is in here, we square it, we get what our n. That gives us 61 point that. Then you can put all this in your calculator. We round it up, always your n. You can't get a decimal n. So our n is always the whole number. So round it up to the nearest whole number and you're good to go. So this is for what? Mu. When we go to proportion, we do the same. So we want to find the sample size. So we are giving the details that we need. 99. So if you have 99, our C is 99. Alpha is that read sigma of what? Alpha over 2 from your calculator, and you're going to get that. Insert the formulas. So alpha over 2, sigma alpha over 2 give us that. And we have the sigma to be that. Z alpha over 2 give us this. And sigma gave us that, and E, because within, I think, yeah, within, so we have E to be 0.1. So we found that, round it to, so we have 42, round it to, right, irrespective, don't count, just round it. If there are decimals, just round it up, just round it up, just round it up, rather. Okay, so now we are done with the mean aspect. We are going to the proportion. Okay, so when you go to the proportion, the E also was there. So realize that the E part for the proportion was like, we have Z alpha over 2, then you have the square root of P hat multiplying 1 minus P hat all over hat n. Okay, the n was found here. So this is the within E. So if you do change of size, you're going to get n. So for n, you're going to get all these. So that is what they did, or we did here, to get the formula. Okay, so this formula you don't have to put in the brain, you always be provided. Okay, but note, most conversation estimate, the estimate obtained using P, which gives the largest estimate of n. Okay. Most conservation estimates, the estimate obtained using P. So if you use P to be 0.5, which gives the largest estimation of n. Okay, so this is a uniform thing. So minimum sample size for the population proportion example. So let's get to solve some example. So find the necessary minimum sample. So we want to find n. What's the confidence interval? 98. Okay, so your alpha is 0.02 divided by 2.01. Read it or use your calculator. You're going to get it to be this. So you go to the formula that tends to estimate. So you have to get your z alpha over 2. Then you square it. So that's what you did. Then you get our p hat. What is the p hat? Interval for p within a margin of error. So given the e, this is our e. We square it. We put it here. So now here we didn't talk about. So assuming that no prior knowledge about p is available, then you assume that p and q are equal. Okay, so p and q are equal. Of course, within the formula, you have to get p, you have to get q. So this is the formula that you are using. You can also use this formula. All of them works, but this is what you are using first. This is what you are using now. Okay. So p and q are given with no prior knowledge. Yeah, they should be equal. You know that for proportion, they should be up to 1. So if they are equal, then it should be split together, 0.5, 0.5. So assume that prior suggests that. So now we know P to be at 0.1 with the same information. So now you change P to 0.1 and Q to be equal at 0.9. They should always sum up to 1. So if P 0.1, Q is that. Use the formula and you're good to go. You get your sample size. So in case you can't work it within, then you can input all these formulas in your calculator. Always remember to round it up. If it is 190 something, then round it up. So 194.8 gives us 195. Okay, that is the sample size estimation. Use the formula, just input. So you have within a number that counts as your A. And put in what you have to find is your Z alpha over 2, and you have to know where your E is. So you have another question, okay? So we have the C to be 98%, and so alpha is 0.02. So what again information do you have? So what size sample should we obtain if we wish to estimate to within 2%? So our E is 2%. Okay. What is here is our E 2%. Okay. So we have it here using the formula. So we have Z alpha over 2 squared. We have P. So he uses 2006 estimate of 15% obtained from okay, so this is our P. That is 15%. So if 15%, then K will be what? 85%. Are you okay? You should always sum, all these two should sum to 1 or 100%. Then you're good to go. So insert the formula and it gets n to be this. Always round it up, okay? He does not use any prior estimate. So P and Q. So with this one, if you don't have any prior knowledge, then the P and Q are always equal. We do same. Okay, so this is how to estimate the minimum sample size. The minimum sample size, all right? Just so simple as that. So simple as that, nothing to. So you have the mean and you have the proportion aspect. All right, thank you very much.